Hello and welcome to Ask Your Academic. Today's session will cover the MSc Medical Physics, and we're joined by Dr. Claire Tarbert and Dr. Mark Mcjury, and they're here to answer any questions you have about the programme. We are recording this session today, so don't panic if you miss anything. We'll send the link out hopefully today to let you watch that back. I'll pop some helpful links into the chat box as well, so if you've got any questions about accommodation, funding, things like that, that'll be a good place to go to. Also after the session, don't panic if you've not had your question asked or if you think of anything. I'll share the administration email address and you can follow up with that afterwards. So let's not waste any time. Claire, Mark, would you like to introduce yourself and then tell us about the programme, please?
Sure, thanks very much, Naomi. I will just start by sharing my screen. Can you see that okay? So is that all right, Naomi? Yep. Okay, great. So yep. Yeah, so I'm Claire Tarbert. I am the programme lead for the MSc in Medical Physics. And that's not my main job. My main job is as a clinical scientist in the NHS. I'm just going to adjust the slide deck here. But I have an honorary position at the university, and that's true of almost all of the teaching staff on the MSc in Medical Physics. So the vast majority of us are NHS staff in Glasgow with an honorary position at the university. And then I'll just hand over to Mark as well.
Thanks, Claire. Yeah, similarly, I'm a scientist in the NHS in medical imaging, and I also have a position, an honorary position at the university, and an involvement with the MSc. Yeah, that's neat.
Okay, great, thanks. So Mark covers the research project, so he can hopefully ask some or answer some questions on that when we get to that point. I was just going to start with some brief background on the MSc to give you some context and understand how it came about. So our MSc, this MSc in Medical Physics, was first developed sometime in 1993, and its original aim, or the original reason it was put together, was as part of a training scheme. So it was originally developed as part of a postgraduate training scheme in the NHS, what we now call the Scottish Medical Physics and Clinical Engineering training scheme. And that training scheme includes a knowledge component, so an academic component, and also a work-based training component as well, where you go into the workplace and you learn practical competencies as well, or you become competent in practical skills as well. The successful endpoint of that whole training scheme is HCPC registration as a clinical scientist. So both Mark and myself are clinical scientists. So that would be the kind of qualification you would get from that training scheme. But I just want to highlight that this MSc does not deliver that. This MSc is about delivering the academic component. So while originally, the MSc was developed to serve the needs of the NHS and our trainees, in the 20 years since it was first developed, or the 30 years rather, it's expanded beyond that. So we now have a lot of international students who come on the course because the core elements of medical physics are the same, whether you're from the UK or whether you're from Mexico or whether you're from Greece. And we also have a lot of students who go on to work in other fields as well, so who don't necessarily work in the NHS at the end of their time with us. So yeah, not everyone goes on to work in the NHS, and these are some typical other destinations that the students might land in after the MSc. So a significant number do go on to undertake work-based training in the NHS. So they go on to a training scheme hoping to become a clinical scientist. Many of our students will apply for or take other jobs in medical physics, either in the UK or outside of the UK. Some of our international students may want to return to their home country to work there. And we do have a significant number who go on to do PhDs in medical physics or closely allied areas of research. One thing I wanted to flag up is this is quite a small programme. Typically, we have between 3 at its very smallest and 13 students. So it's a little bit unusual in that respect. And we do put together informal career sessions throughout the year. So those are mainly networking sessions that we put together between the students and people who are working in various areas of medical physics. So we try to support you in your career after the MSc. So, as I said, Mark and myself both work in the NHS, and we have these honorary positions in the university. And the vast majority of the teaching is done by NHS staff. So we have some core courses that are delivered by full-time academics, our anatomy module, the statistics teaching that our students get are delivered by academics, but everything else is delivered by up to about 80% of the top programme is delivered by NHS Medical Physics. And there's advantages to that. It means you're being taught by frontline NHS staff who are putting this knowledge into practice on a daily basis. So they should be at the cutting edge of medical physics. But the other side of that is they're also going back to a busy clinical practice immediately after their lecture with you. So they might be rushing out the door to go see a patient afterwards. So I'll just say a little bit more about who we are. So the NHS, because I think that is important. The NHS in Glasgow is one of the biggest health organisations in the UK. Depending on what measure you use, it's the second or third biggest. So we provide healthcare services to a huge population, to 1.2 million people. We have 38,000 staff or thereabouts. So it's a really huge institution. And to mirror that, or in line with that, our physics and engineering department is also one of the largest in the UK. So we've got about 330 staff, and we cover all of the core areas of medical physics. So we have staff in radiotherapy, nuclear medicine, clinical engineering, radiation protection and diagnostic radiology, and MRI. And because, so we're a very big department, which is not always a great thing. But one of the good things about it is because we're such a big health board, because we're such a big physics department, if there is a new technology being introduced into the NHS, it'll very often be introduced in Glasgow. So I think that's quite an important thing to say. And the services that we're providing are huge. So our radiotherapy service is a regional service. So we provide services out with Glasgow. And we are providing radiotherapy to 2.6 million people. So almost half of the population of Scotland will be served by our radiotherapy physics department. We have 24 clinical MRI systems in Glasgow that our department supports, as well as a fairly unusual, there are far fewer within the UK, high field strength 7 Tesla MRI scanners. So we have one of those in Glasgow as well. And we've had research projects take place with the 7 Tesla facility in Glasgow. So quite a few of our students have worked on that. We also have a very big nuclear medicine service. So we have 18 gamma cameras spread out across the city. And we have 2 PET CTs at the West of Scotland PET Centre. We support more than 800 pieces of diagnostic radiology equipment, and we manage more than 60,000 medical device assets. So it's an absolutely huge service that we are supporting, and the teaching staff are familiar with a huge range of these areas of medical physics. So what's in the MSc itself? Well, it has a fairly standard structure. It's 180 credits in total, where a credit is a measure of the amount of time we expect a student to spend to complete the course. We've got 120 credits of taught courses plus a 60 credit research project, and that's roughly a third of those credits are in the first semester, a third are in the second, and then the research project is a third of the credits, which is over the summer. The programme contains a mix of topics on general scientific skills that you would need to work as a clinical scientist in the NHS. So we have an anatomy and physiology course. We don't have any expectation that you will come into this MSc with background knowledge on that. We get you to do a course called Evidence-Based Biomedical Research Methods and Statistics. So statistics is really a key basic skill for any scientist working in healthcare. And we get you to do a programming course as well, and that's another key skill that we would expect a physicist to have. And then the rest of the modules are made up of specialist subjects. So this is the specialist knowledge that you would need to work in a medical physics department. So we've got a radiotherapy course, that's a key area of medical physics. We've got 3 imaging modules to cover both ionising and non-ionising radiation modalities. We have a clinical measurement and scientific management course, and those are areas that we in Glasgow specialise in particularly. And then finally, we bring everything together in a research project, and that's a chance to go away and get some more hands-on specialist training in a specific core area of medical physics and apply the knowledge that you've learned through the taught courses. So we had a couple of questions specifically about the research project. So this slide is trying to answer that. So the research project will take place after the semester 2 exams. And for us, that's usually towards the end of April, beginning of May. They run for 16 weeks over the summer, and the assessment is we get you to write a dissertation, we'll get you to do a poster and a presentation, and then there'll be a final Viva exam on the dissertation and the work that you've done. We're very lucky in that in recent years we've been able to offer you a mixture of projects, some of which are based in the NHS and some of which are university based. And typically we are able to offer projects in radiotherapy, in nuclear medicine, in MRI, either within our kind of core clinical services or at the 7 Tesla facility, or in data mining as well. So it's quite a broad spread of projects that we have been able to offer in the past. We had some questions around logistics, specifically about where the teaching would be held. And certainly our aim, and in the past few years, teaching has been split between the main university campus, which is this nice image that's shown on the right-hand side, and the Teaching and Learning Centre at the Queen Elizabeth University Hospital, so the newest hospital in Glasgow. But we would send you to other clinical sites for some practical sessions throughout the year. So just to visualise that, the Queen Elizabeth University Hospital is on one side of the river and the main campus is on the other side of the river. So it's about 20 minutes to cycle between the two, or about an hour to walk it if you're looking for some fresh air. These are some of our other clinical sites around the city that we would expect to send you to throughout the year. We had a question around practical sessions, and we do try to get you into clinical settings as often as we can, although we are limited by our clinical commitments as well. We've got patients to see. But we have some standard scheduled practical sessions that we offer throughout the year. So in semester 1, we have a practical session in a CT room at the Queen Elizabeth Hospital. So that's typically between 1 and 2 hours, where we get you to scan a phantom. We also do an ultrasound practical in semester 1, where we'll likely get you to scan your pals or me. And we also offer a radiotherapy tour and a practical session in semester 1. In semester 2, we'll get you into one of the MRI facilities, again, to scan some phantoms, maybe some fruit. And we have a longer session in a nuclear medicine department in semester 2 as well. So we'll get you to spend a half day in a nuclear medicine department scanning phantoms there as well. We will send you into one of the niche areas of medical physics, so electrophysiology, for a clinical measurement tour. And where possible, we weren't able to do this last year, but we would give you a tour of our cyclotron facility as well. And then finally, the research project. So the research project will vary year to year, or the ones that we're able to offer vary year to year. And it will also vary depending on what project you choose. But it very often will contain a significant practical component in an NHS facility. So that could be image acquisition on an MRI scanner or replanning radiotherapy treatment plans. So that is very often an opportunity to do more practical work. And then this is just my final slide. So these are the last few questions that we had. So the first one was how many hours or days are we likely to be on campus? And it's typically based on the last few years that you would be on campus 5 days per week, and it would be between 2 and 4 hours of classes per day. And what I would just highlight is that's probably a bit higher than you're used to if you're coming out of an undergraduate physics degree, and that we are a content heavy course. So the programme would be different to an undergraduate physics degree, where your focus is on learning key principles and then learning how to apply them for the exam. The very nature of medical physics means we need to give you more content before we can get you to the problem solving stage. So there's a high volume of content that we will need to deliver when we're teaching you. Do we get access to material before class? So all of our slides all of the PowerPoints should be up and available on our online learning environment at least 24 hours before the lecture. And we also have a small number of courses that are delivered as pre-recorded anytime lectures. So the recording would be made available at the beginning of the week, and you would have a follow-up tutorial or seminar at some point after that. And we had a question on how to start preparing for the MSc. So the first thing I would suggest is that you could do some background reading in medical physics. So try and orient yourself within the field as much as possible. That might help you with some of the jargon, as you know, it'll be a less steep learning curve for you. And then the other thing, just coming back to this idea that the program would be quite different to an undergraduate physics degree. So I would start to think about how you might approach a different style of teaching and learning, you know, how you're going to manage this content that we're going to deliver to you, how you might adapt your studying. So I think that would be quite important. So I think that's all that's in my slides. Mark, I don't know, I know you got these slides fairly last minute. I don't know if there's anything that you would like to add to that or anything you feel.
No, just one wee tiny correction. Just the project slide listed 16 weeks, but we've moved recently to 12 weeks for the project.
Right. Yeah.
So, but otherwise, yeah, so it's spot on.
Naomi, anything else you'd like to?
I maybe I missed it because there was a lot of information there, and I was reading it and I was looking at all the kit and stuff that was sort of shared. The in terms of the research project, when do students typically choose their topic? When does that list of topics come out to them for them to pick?
Sure. Mark, do you want to cover that?
Sure. It comes out in the spring. So typically, sort of February, March, we'll finalize the list. We'll distribute the list of projects to the students, and we try and get them to choose their favorites out of the list. And we do our best to sort of try and fit a good fit for the necessary skills of a particular project and what the students are most interested in. And we generally are able to offer people their first or their second preference of project, whether that's a clinical one or whether that's a sort of more academic one. And it tends to work reasonably well. We have an online Teams session also where we get all the project supervisors together and all the students together. The supervisors give a little overview of what the project involves, what kind of skills are necessary, what kind of outputs are expected, and the students and the supervisors get to have a nice kind of Q&A session, which helps students pick the most appropriate project for their interests and aims.
And Claire, you mentioned that the class sizes are quite small. Do you find that the students really kind of bond and get quite tight relationships?
Yeah, inevitably they do. So you can't help it if there's only a small number of you in the class. You get to know your colleagues, and I think that can be really useful. They can provide support to each other in terms of adapting to the different teaching style that we've got. So yeah, I think they value it.
Great. I think all the questions that I had beforehand have been answered, and there's nothing come through the. Oh, here we go. Just as I was saying that, we've got one pop through there, and it's the practical sessions. Someone's asked are they hands-on or are they observational?
I can speak for the ultrasound. It's very hands-on. We would expect you to have an ultrasound transducer in your hand and be scanning something. And that is, it varies slightly depending on the nature of the practical. With the CT practical, the aim of that is, yes, to get you into the CT room and to be pressing buttons. So to be pressing buttons on the machine and scanning the phantom. In the MR session, it would be, you would be involved, but it would be, you would have less control over the buttons. I think that's fair to say, Mark, isn't it?
Yeah, I mean, two things there. The MR environment is a very controlled environment, so you probably wouldn't go into the actual scan room just because that would require you to go through health checks and such. And similarly, the interface of an MR scanner is very sophisticated. So it's more of a, asking questions and suggesting things to try out and watching the scanning happening and, getting as close as you can to sort of guiding and the scanning. But yeah, you do need support from an expert to run the scanner.
That's great. And I suppose you mentioned in the research project, but you maybe wouldn't be in control of it, but I suppose you would maybe get a bit more exposure to some of the equipment during your research project.
I think that's absolutely right. The idea, I guess, of the research project is that it's a win-win. It's that students having it appears at the end of the course and all the knowledge and the skills that students have acquired during the course. It's an opportunity for those 12 weeks to roll your sleeves up and actually get your hands on some equipment, make some relevant clinical measurements that a clinical scientist would typically do in their day job, to actually spend that time in a clinical environment or an academic one if that's what your interests are, but actually, work with jobbing medical physicists, and often you'll be doing something which is not just a pedagogical exercise. It's something that it's some development work that's important and necessary for the clinical service, and so you get the opportunity to use the relevant equipment, to look at the guidelines, to implement and can develop techniques. So hopefully it's something that's useful to the researchers or the clinical scientists or the service, and it's something that's really useful for the students as well.
We are in the time there. We are coming up to the end of our session, and we've not got any other questions that have came through there. You have answered all the questions that we had, so I don't know if there's anything for the last couple of minutes that you feel that we've missed or that you would like to mention before we close out for the day. Quite happy.
Yeah, I think this is quite a unique program, and maybe just coming back to the fact that it's generally quite a small program, a small cohort of students, and mainly NHS facing staff. So it's quite unusual, but I think that can be really valuable as well. You would certainly have a different experience in another university with a different organisation if it's more academic staff. But I think that is something that we have that's quite unique, and we'd love to welcome you to Glasgow. So that's all.
Thank you. I think it's actually just worth mentioning there, as much as it's a small cohort, don't think that's the only people that you'll mingle with throughout your year. There's loads and loads of societies and loads of things for students to get involved with. So there is then the opportunity to meet people out with your programme as well. Yeah. So like I said, if you think of any questions when you're watching this back, or if there's anything that comes to you just after, please do get in touch. I've popped the administration email address into the chat box, and you can find it on the webpage as well. So yeah, the administration teams are brilliant, and they can pick up with you on anything. And we will aim to send the recording out today for you so you can watch that back. So I think all that's left to say is thanks very much, Claire and Mark, for taking time out of your busy schedule to run the webinar today. And hopefully we'll see you all in September. So thank you very much. Goodbye.
Bye.